Welcome back to my channel. Today we will be discussing about the Lewis structure for nitronium ion. To write the Lewis structure for nitronium ion, first we have to calculate the total number of valence electrons. For this, we have 5 electrons from nitrogen, 6 from oxygen. There are 2 oxygens, so 6 into 2. And this is a plus ion and there is a positive charge. So you have to reduce 1 electron. So the total number of valence electrons will be 5 plus 12 minus 1, that is equal to 16. In the second step, you have to write the skeletal structure where nitrogen is taken as the central atom because it is the least electronegative atom, and oxygens are put in the terminal positions. Now you can draw single bond between nitrogen and oxygen using the valence electrons. Here you can draw 2 single bonds, and these 2 single bonds need 4 electrons. And now the available valence electrons will be 16 minus 4, that is equal to 12. And these 12 electrons can be used to fulfill the octet on each oxygen atoms. 6 are used here. Again, 6 more electrons are used here. Now the available valence electrons will be 12 minus 12, that is equal to 0. Now in the third step, what you have to do is, you have to check whether octet is fulfilled for all the atoms. Here from this structure it is clear that octet is fulfilled for these 2 oxygen atoms, but what about nitrogen? There are only 4 electrons for nitrogen. It needs 4 more electrons to complete the octet. So how can you solve this problem? To solve this problem, you can rearrange electrons on oxygen. You can shift this electron pair to this bond and make a double bond between nitrogen and oxygen. And from here also, you can shift one pair of electron from this oxygen atom to this bond so that a double bond is formed between oxygen and nitrogen nitrogen will get the complete octet. So the structure will be like this, with the double bonds between nitrogen and oxygen. Now it is clear that there are 8 electrons in the valence shell of nitrogen, because from these 4 bonds nitrogen will get 4 into 2, 8 electrons. Please note here that after rearranging, oxygen has only 2 lone pairs here, and here also this oxygen has 2 lone pairs after rearranging the electrons, but still they have the complete octet electronic configuration. Now the final step, you have to assign the overall charge on the ion. For that you have to calculate the formal charge. How can you calculate the formal charge? Formal charge is equal to the number of valence electrons of an atom minus the number of electrons assigned to that atom in the Lewis structure. Here nitrogen and oxygen are the 2 different atoms. The electronic configuration of nitrogen is 2,5 and that of oxygen is 2,6, and so the number of valence electrons for nitrogen is 5 and that of oxygen is 6. And from the Lewis structure, the electrons assigned to nitrogen is 1, 2, 3, 4. Okay, so its formal charge will be equal to 5 minus 4. 5 is the number of valence electrons and 4 is the number of electrons assigned to nitrogen in the Lewis structure. So its formal charge will be 1. And here The number of electrons assigned to oxygen is 1, 2, 3, 4, 5, 6. So its formal charge will be 6 minus 6, that is equal to 0, where this red 6 is the number of valence electrons and green 6 is the number of electrons assigned to oxygen in the Lewis structure. So the final Lewis structure will be like this, with a positive charge outside the square bracket, and it is clear that this positive charge comes from this nitrogen atom because these two oxygens have 0 formal charge. So like this way you can write the Lewis structures for small polyatomic ions. You can try it out. Now we are going to see the Lewis structure for a negative polyatomic ion, that is nitrate ion. Here also the first step is to count the total number of valence electrons. So that for that we have 5 electrons from nitrogen, 6 into 3 from 3 oxygen atoms. Then here this is a negative ion and there is one negative charge, so you have to add 1 electron. So the final valence electrons will be 5 plus 18 plus 1, that is 24. In the second step, you have to write the skeletal structure. Here also we will take nitrogen as central one because it is the least electronegative atom, and we will put oxygens in the terminal positions. And here we can make 3 single bonds, and these 3 single bonds take 6 valence electrons from 24. So the available valence electrons now is 18. And this 18 electrons can be used to complete the octet on the more electronegative atom oxygen. 6 are used here, 6 are used for this oxygen, and 6 more are used by this oxygen atom. Now the available valence electrons will be 18 minus 8 is, that is equal to 0. In the fourth step, we have to check whether octet is fulfilled for all the atoms. Now from this structure it is clear that all the 3 oxygen atoms have stable electronic configuration, but nitrogen needs 2 more electrons to complete the octet. And what you can do is you can rearrange electron pairs on oxygen to this bond and make a double bond between nitrogen and oxygen, so that you will get 8 electrons in the valence shell of nitrogen. So here I used electron pair from this oxygen. You can use any of this oxygen for rearranging the electron. So in the final step, you can find the formal charge to assign the overall charge on the ion. Here the formal charge of nitrogen is 5 minus 4 because number of electrons assigned to nitrogen in this case is 1, 2, 3, 4. So its formal charge is plus 1. And the formal charge on double bonded oxygen. Here the number of electrons assigned to this oxygen is 1, 2, 3, 4, 5, 6. So its formal charge is 6 minus 6, that is equal to 0. And for this single bonded oxygen, the number of electrons assigned is 1, 2, 3, 4, 5, 6, 7. So its formal charge will be 6 minus 7, that is equal to minus 1. And for this oxygen atom also minus 1 because its situation is similar to that of this oxygen atom. So the overall charge of this nitrate ion will be -1 because +1 and -1 charge will be cancelled. Then overall charge will be -1. That can be from any of these single bonded oxygen atom. So the final Lewis structure will be like this. This structure in a square bracket, and you have to put -1 charge outside the square bracket over here. I hope you are clear how to write the Lewis structure for positive and negative polyatomic ions. This is very simple method. You can follow this method and can write the Lewis structures for any of the polyatomic ion given.